Hi, this is Miss Goodale, and today I'm going to be talking more about solving equations. This time we're going to be talking about solving division and multiplication equations. We'll start out with a little bit of a review. We talked about these in the last video. An expression, remember, is a phrase that can have numbers, operations, and variables. An equation is a statement that two expressions are equal. So if I had 5x plus 2 is equal to 10, that's an expression or equation. And 5x plus 2 equals x plus 1 is also an equation. A solution is a value of a variable, which can be a letter or a symbol that makes a statement true, or we can think about that as the answer. And inverse operations are operations that cancel each other out, which basically are opposite operations. So addition and subtraction are inverse, and multiplication and division, which we will talk about in this video, are also inverse. So just like the last video, I want to start out with an example with using the blocks to model, and then we're going to go right into doing the problems without the blocks. So again, I'm using the long green stem or tens as x's. So they don't have any value. We don't want to think of them as having a value because it's a value that we don't know. So we'll start out with those. And in these, when we multiply 5x equals 10, that means we have 5 x's. So we have 5 of these. And then on the other side, we're going to put just our regular blocks. And I'll try to count out 10 here. Okay, so we should have 10 blocks. Now on this one, if we remember how multiplication and division works, we know that multiplication is groups of values. So instead of taking out to cancel out, this time we're going to match up. So if I have 5 of these on this side, I want to have 5 groups on the other side. So I'm going to have 1 group, 2 groups, 3 groups, 4 groups, 5 groups. 1, 2, 3, 4, 5. And so I have to make sure my groups are equal. And so if I look at this, I know for every x, there are 2 little blocks. So that means that x is going to be equal to 2. So in order to draw this, it's going to look basically the same as what I just showed you. I'm going to write 5x blocks, and then I'm going to erase my line and just draw an equal sign. Equals, and 2, 3, so then I'll do my circles to show that they're in groups. Okay, so each group is 2. That means my x would equal 2. Now, let's move on to doing this kind of problem using inverse operations. If I were going to do this without doing the models, just like on the other video, we know 5x is the same thing as 5 times x. So it's basically saying 5 times x equals 10. And I know if I multiply, the opposite of multiplication is division. So let me write that in a different order, because when we think about it as x times 5, it can kind of make it easier to understand. So if I think about it as x times 5, then I can do x times 5, and the opposite is division, so I divide it by 5, and that equals 10 divided by 5. Okay, you remember when you do multiplication, you can do multiplication in any order. So 5x and x times 5 are the same. That's why I rewrote it in a different order, just so that we could do this and make it makes a little more sense to you guys. So notice that I put the division on both sides, because that's what I added to the equation, or what I put in there. The times 5 is not going to be repeated. It's already in the problem. So all I have to do is solve. Now the times and divided by 5 are going to cancel each other out, so you're left with x on one side. And then 10 divided by 5 is 2. So x equals 2, and that's exactly what we got up above. Okay, so now I've written some problems here to make it quicker. So 6b is the same thing as 6 times b, or b times 6 is how I'm going to write it, equals 42. Now since it's times 6 here, I have to do the opposite to get rid of that 6, which is division. So times 6 divided by 6 equals 42 divided by 6. This cancels each other out, and we are left with b on one side and 42 divided by 6, which is 7, on the other side. Now this one looks a little funny, but I wanted to show you this because I want you to think of a fraction as division. Okay, so z over 3 is like z divided by 3. So I'm going to go ahead and rewrite that. Z divided by 3 equals 5. So now that kind of helps us to know what to do next. The opposite of division is multiplication. So I multiply by 3 to get those two to cancel each other out. Excuse me. And then that means that I have to put the multiplication on this side. So this is what I put in. Okay, those two balance each other out. I did the same thing to each side. This divided by 3 and times 3, that means they cancel each other out. You are left with z. And 5 times 3 is 15. Another problem I thought you might want to a little bit info on is 2/3 a. This is like 2/3 times a. So I'm going to rewrite that over here. Times a equals 16, and times a is 2/3. So I'm rewriting that the other way around. Now I can figure out what operation I do to undo it. So it's multiplied by 2/3 there. That means I have to divide by 2/3. Okay, those cancel each other out. And that would be 16 divided by 2/3. And if you remember, I'm going to go ahead and write out something to help you remember. When you divide by a fraction, it's the same thing as flipping over the second number and multiplying. So you would do your 16 times 3 and your 1 times 2. And you have, oops. (48 over 2), which is equal to 24.